This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
This is Sven Johan for Software Engineering Radio. Today I have with me Dave Thomas. Dave is the founder and chairman of Badera Research Labs and an ACM Distinguished Engineer. He received this award for his contributions to object technology that includes IBM IDEs, virtual machines, and the open source Eclipse Foundation. He's also a thought leader in large-scale lean and agile development and the founding director of the Agile Alliance. Today I will be talking with Dave about innovating legacy systems. Dave, welcome to the show.
Hi, it's great to be here, Sven.
I want to mention that the feedback of the listeners is very important to us, so please help us improving our show and leave your opinion via Twitter, Google+, or LinkedIn. Dave, did I forget to mention anything important about you?
No.
Okay. What is a legacy system?
A legacy system is something that's important to your business because it's generating revenue for your business, keeping your customers happy. It's called a legacy for various reasons by young people because they want to turn up their nose because it's not in their programming language or methodology, perhaps because it's older technology, but it's also a legacy because it's established, and in many cases it's the core supporting system for the business, and it is the legacy of past innovations in many cases.
It has a bad reputation in software development. Why? What are the problems?
I think software development often is focused on, we teach people about greenfields, so most new software developers are keen to use the latest technologies, the latest methodologies, and we aren't always that great at documenting our systems or making them testable and so on. So often systems have been around for a long time, have become very difficult to change. One of the problems, of course, is that any good software probably needs to be killed and rewritten after its third release. So when you find things that have been, not overall, but in part, when you find things that have not been refreshed and redesigned and so on, and they're, approaching their 7th or 8th release, then they are very, very difficult to work with and to change, so they can become very, very frustrating. And often they're on technologies that people aren't familiar with and are certainly less malleable and less agile than people would like them to be.
You mentioned education, that we get only taught how to work on greenfield projects. Is it necessary to change the curriculum at universities?
I don't know if it's necessary to change the curriculum. I think it's important to give people awareness of the complexity of reality, and that we have to, in general, you always have to deal with technologies that are you need to be able to take on new technologies, which is one of the problems people become. They graduate with Unix and can't do anything beyond Unix. And you need to be able to deal with past technologies, because any established business has core systems that were built in previous technologies. So I think it's really more a healthy respect and an understanding for the strengths and weaknesses of different generations of technologies and just different methods. I think it's also important to understand the difference between what a single programmer can do and what large teams of programmers can do, in the sense that even the best practices of refactoring are really a joke in the context of a large legacy application. Refactoring tools really don't help you with large legacies. Mm-hmm. So I think we teach a lot about programming in the small, which is natural because universities are limited. I think having a a background in sort of systems engineering or software at the systems level is important because large systems are very different than single applications or websites.
Good. But how can we deal with legacy systems? So I think there are a few, in my opinion, bad systemic approaches. So I was quite often in the big rewrite, which mostly failed. Do you have an opinion on rewriting these systems?
Big rewrites fail. Outsourcing tends to fail. Most of the classic approaches fail, I think, and that's because systemic change is very difficult. I mean, the difference between actually solving a problem that matters to the business by tactically approaching part of the value chain and cracking it is much more important than trying to, rewrite an entire application or do something like that. So, and shipping it to someone else doesn't really change the problem. It may temporarily reduce the economics because the cost of the programmers is cheaper, but even there, the cost of the programmer increases when you send it offshore because they're getting better paid for the better people, and you lose the fact that you don't have the domain knowledge.
But we all tend to say we need to rewrite it and do it better. What are actually the problems with rewriting?
Well, the problem is you in many systems you don't have a specification for, you don't have tests. So unless you're prepared to build a substantive body of tests and have the appropriate documentation, it's very difficult to accurately rewrite it. The other thing is there's immense pressure during the rewrite to add functionality. So these are not like, refactoring is supposed to be equivalence preserving. Rewrite is never equivalence preserving, and it's never really refactoring, even though it's often cloaked in this to tell the management, see, it's good, we're doing refactoring, but that's really, nowhere near refactoring in the technical sense. I think it's the fact that it just naturally turns out to be a lot more complicated. People typically don't really understand the system before they start changing it. And it's just, in many cases, getting a new system that was in language Y on machine Z, in language C and machine Q, is that really that does the same thing? Who really wants that? No one really wants the system rewritten in another language. They want a better system.
Yeah, you don't get anything out of it.
And there's no value in that. So I mean, I've watched people go and go to a board and say, look, we need to spend $85 million to move our systems to a modern platform, and that's a lot of money to get essentially the same thing.
You could argue, it's not the same thing because we reduce technical debt, or we need to have a modern system to retain our good developers. Is that a valid argument, or is it?
In my view, neither of those is a valid argument, though certainly they're used. The real issue is you have to have a measure for that being true, right? In the sense that, if you can actually demonstrate that this is true, then I guess you can construct a business case. You may be able to get, say, you're doing it in Java, C#. You may be able to get those developers, but are they really good developers? Are they as good as the ones you had before? I really don't think that. I don't think rewriting a system is really ever justified. I can see building a new system, building critical pieces of that new system, using new technology, gradually replacing it. Clearly those things make sense because they're driven by some clear business value and timeline. But if you can't deliver functionality every quarter, then a rewrite can take minimum a year, sometimes 2 or 3 years, and I don't think any business is really interested in waiting for that amount of time. Businesses still like things to happen in a quarter, and you're not going to rewrite much of a major system in a quarter.
That's true. Yeah, probably takes minimum 2 years, and you're also chasing an existing system because most of the time the developers also have to maintain and enhance the old system, right?
Well, and you also create this culture typically of the, sort of the tiger team. We're going to do the new system, so you have these people who, get bragging rights because they're programming in the new language with the new technology, and inevitably they start talking about, well, we're going to do this and this and this, and so the system expectations grow, and so managing that's very difficult as well. Rewrite is just a loser's proposition. I mean, it's about as stupid as adding more people to a project. There's still lots of people that don't accept that one either, but both of those are well-known facts for failure, right?
So the only possibility is basically don't join these projects if somebody says we want to do a big rewrite. You really have to fight against that.
Well, yes, if someone says we really have to make a major change in our software, then I think that's the high ground. So what's really the issue? And anything that's justifying a rewrite, hopefully is more than, well, we can't hire programmers, or we can't maintain it. It's probably driven by some critical business needs, and it's much easier to attack those parts of the system where you can really deliver business value or really reduce cost, and apply the innovation at those focus points, and gradually change the way your business operates over time.
Yeah, I think in one of the past shows we had the example of Twitter. They started writing their application as a Ruby on Rails app, and then the user base grew, and then it didn't scale anymore, and that was a reason for a partial rewrite. That would be an example.
Yes, they also didn't have any virtual machine expertise to improve the Ruby virtual machine, or they probably could have done it that way too. I mean, there are different solutions for the problem at hand, right? I mean, sometimes it's just that a whole lot of people don't want to program in a given language, so they decide that, one thing is bad another. In the case of Ruby, the problem is that the performance and certainly the maintainability of some of the Ruby code is more challenging because you can write it a lot faster. And anything that you can write in fast is good news and bad news, because you can create a lot more code that you have to maintain quickly. But you have the advantage of getting functioning code quicker. So it's a trade-off in how you manage the software engineering. And again, I think one of the things is that when people use companies like Twitter, these companies have a lot of money. They can hire the people they want to hire. So that presents a different opportunity. The systems are also a lot less complicated than many of the commercial legacy systems that run. I mean, I'm not saying that Twitter is a simple problem, but it's a lot less complicated in terms of the amount of functionality and regulations and procedures and so on than say a legacy mainframe system.
Yeah, I can imagine if you think about Twitter or Google applications, they don't have that complicated business logic, I can imagine, compared to an insurance or a bank.
No, that's certainly what I would assume. Not an expert in any of those. So.
Okay, so we had the bad approaches. Any bad approach I forgot to mention? So we had don't outsource it, no big rewrites.
And no SOA solutions, probably the other one.
But what is a good way of improving the system? So you mentioned we have to deliver value first, so it probably means we have to understand the business and first before we can do anything.
Yeah, I mean, the normal thing is that, any business has experienced a degree of pain, which is either, we take the lean thinking approach. It's basically there's a software value chain, and that value chain is being impacted negatively in one way or other. So typically there are critical points in the value chain where making a difference would have a big impact. And so the approach we favor is that you basically find that part of your value chain which is a bottleneck, or where accelerating it in some way or improving it in some way can make a difference. And that's a place where you can employ innovation. And if you can find a way to change the value chain there in a period of sort of 3 or 4 months, then that's a place to apply where an innovative solution probably will get the support of management and will be able to deliver. And so the approach we use is we basically do a very quick prototype in a few weeks to to demonstrate that the innovation will actually solve the problem. And then we validate that will work at scale, because often you can have something that demonstrates an innovation which won't scale, and then we go and implement it. So it's a pretty straightforward approach.
Yeah. How do you figure out the value chain? Is it interviews with the business people or with everyone involved?
You usually don't need to do interviews with everyone involved. I mean, usually if you talk to if you're working on something important, you can usually ask the senior executives, what's the most important thing that you need changed with regard to your systems or your, usually they know. You can also talk to to some of the key developers and so on. You usually don't have to do a lot of interviews. And you probably will do some measurements to validate that their assumptions of where the time is spent, or where things are slow, are actually valid, because people sometimes have intuitions, particularly about legacy systems, that there's some big problem, over here, right? And often it turns out that the problem isn't where they think they do. But you should be able to find out what the major problem is inside of 2 or 3 weeks. They usually jump out at you, and the value is usually clear. They're typically, they have to be worth, in a major organization, unless you're going to solve, $5 or $10 million, or possibly more, or save them, in general, I don't like working on things that don't save like 20% or, 15 to 20%, of the total cycle time. Otherwise it's just not worth it.
Yeah, I think Tom DeMarco said something like this: if you build a system which improves only 10% of the current status quo, just don't do it. If you double it or 20%, then it's...
To me, you're really you'd like to look for 20 to 30% improvement on the thing that you're trying to, that may only result in sort of 10% overall to the system, but the thing you're improving, you should be making a significant improvement in.
Okay.
So it's not particularly complicated. Then you have to find what's the innovation. So that's the creative part. Okay, so we understand the problem. We understand what the value of improving it would be. If we could improve it by this amount, then the innovation typically has to enable it getting done quickly and fairly inexpensively, because clearly the other solution is, well, we just rewrite it all, or rewrite this portion of it, right? And that may be the answer, but seldom it is. And so that's the chance when you can say, okay, look, we see this problem differently, we look at it through different eyes, and so we can now insert a way of doing things that's quite different at this point in the value chain, and that will, reduce the cycle time or increase the volume of, transactions, or increase the reliability, whatever the thing is that you're trying to improve. And that's the fun part, because that's when you get to innovate. And most legacy systems provide a lot of opportunities for innovation, but typically, unfortunately, software developers approach each of these with their current hot technology. So their solution is not really innovative. It's just use my new, method or tools, right? So that's so they come with new hammers and saws and maybe new smart people, and but that to me is it's certainly an innovation of sorts, but it's really it's not an innovation that's really unique to that problem. Yeah, and so I'm really talking about coming up with a solution that's really unique to this particular business problem and saying, okay, how could we really change this, and how could we get it done very quickly, like in a quarter? And that to me, that means you need to have a clever way of doing it differently. You can't just do it the same way, because you can't rewrite something in a new language or do it with a new process and really have the change working in a quarter.
But if you say you want to improve 30% or 20%, it should be measurable somehow. So I assume
absolutely
a solution like, I want to make the code base nicer or easier to maintain. That is very hard to measure. So probably you need something like, less down. We want to go from downtime X to downtime Y.
No. You need a real measure. Improving the code base so it's easier to maintain is something I would not give anyone $1 for. It's so hard to measure and so hard to do, and that's a never-ending story. The reality is there's always going to be code that people don't like, right? There's always going to be code that smells, right? That's just the way it is, right? Especially if you have a lot of developers. If you really don't want very much code that smells, don't have very many developers, right? But if you have a large system, then you're just going to have that. So no, you're looking for something that's tangible to the business. Statements about improving the code base or reducing the defects, that will matter if the quality is perceived to the customer to be significantly important. But it's much easier to talk about something that will significantly increase revenue or significantly reduce operating costs. Those are things that you can, and to have things that are really measurable. How do you measure, like, the code base is nicer now? You have to fight all over the metrics and so on. And I just don't think, why would a business do that? They're not selling the beauty of their code base, right?
No, but I can imagine if people constantly complain about the quality of the code and say, there is a small change. I can remember one project just adding one field to an insurance policy. It took like 2 weeks because it was really complicated. And if you say, if we spend 2 months on this and then you get it within 2 days, that would be...
Yeah, perhaps. If you knew you had that, again, so I could see doing that. That would mean that you'd have to say, look, we have all these changes we have to get done. And currently the cost of a change is, X. And if we, redo it this new way, then the cost of the change will be one hundredth of X, or whatever it is. Then I could see that as being an argument, provided you're willing to measure it.
Yeah, I think that is the problem too.
So the big thing with us is that we guarantee it will work, or you don't pay.
Yeah. Okay.
Yeah. So basically, if we don't deliver what we say we're going to deliver, and you're not satisfied, then the customer won't pay. You have to. The reason that people make changes in business is because they believe the risk and return is there, and if you're prepared to absorb the risk of the change and benefit from the value, of course, now I'm going to tell you that in return for me taking the risk, it's going to cost you more money than it is to get it from you, your firm, because I'm taking the risk, right? If they go with your firm, you will charge them all the money up until the day it doesn't work, at which point you will say, well, it was risky and we all know, but we tried hard.
Yeah, exactly. And therefore you probably want to have clear measures.
I will define the measures, in fact. I will define the measures, I will agree on what the measures are, and I'll contract that these are the measures we'll use to demonstrate that we're successful. Essentially the acceptance tests, which are really the acceptance tests. That's the clearest measure, right? Your throughput will go up by this, or if you want to take 10 changes to go back to your example, you have these 10 changes. I will guarantee that, I will say, after a week's training, for the people that need to make the changes, they will be able to make, a change per day or whatever it is. So the cycle time has been reduced.
Yeah. Okay.
And I think that's the biggest problem, is that many people are keen to embark upon a project of change, but not keen to be held accountable for the progress or the deliverables. So I think if you're not prepared to provide the insurance and the value that goes with the risk, then your likelihood of having your proposed innovation or change accepted is much lower, because what you're doing is saying, well, look, I will do this thing for you, but it may not work, and so, or I won't guarantee it'll be done in 3 months. You'll probably say, well, it could be 4 months, maybe 6 months. We'll have to see as we go, and I think that's a way to communicate to your executives responsible that you're not really in control, and you really don't understand it well enough and feel confident enough. And I think that lack of confidence comes across, and the executives basically, when they say, well, because the next person will hear, well, we think it's 4 months, but it might be 6 or more, and then they will go to their manager and say, well, we think it might be 6 months, but it might be 10 or more, and so the project grows because each layer is, perceives that there's risk, and so they will pad it even more, right? Versus, I think if it's an aggressive external, and I think most of these things need to be done by external teams. I mean, I don't think most people can do these internally themselves. Unless you have a team that's actually has a track record, right? And that's what you do when you've got a team that's do this. You do one innovation and you apply it, and then you go and find the next most important time, and you move that team and you attack with that team. Maybe you add different expertise, because maybe the first system was a telecom problem, and the next one is maybe a problem that has to do with maybe the mainframe or banking or something. So you have to change the expertise mix of the team. But you typically have, and that's the benefit, is if you have a few of these crack teams in the organization, then you don't have to retrain all the programmers in some new programming language or hierarchy, because the reality is a lot of that system doesn't need to be changed. So you can then spend your money on a few critical, talented resources that will apply the innovations at different points, and maybe over time you'll grow more teams in the organization that will be able to innovate in this way and make innovative changes. But it's a different approach. But I think the biggest thing is basically having a track record of delivery. I mean, if you're prepared to guarantee that things will work, you'll get people's attention.
Yeah, I can assume. I think so.
And that's the difference. I mean,
and then you can probably use any technology you like.
That's right. That's why I've been able to use all sorts of wild and crazy technologies. It's not because people, some of the people and customers who know me actually say, okay, well, whatever, crazy thing you're using now, don't bother telling us about it. We know that, because we don't really actually believe it's the technology, and we think it's the team of people that have a track record for delivery, and in many cases that's actually true. I mean, the reality is if you have a really good team and they pick a technology, they will probably make it work, because they want to be, they're driven by success, not by just using a particular technology.
Just having fun.
And they will abandon, and the good ones will abandon a technology, say, no, this was the wrong approach, so we're not doing this. They will absorb the cost of doing that, and then they will say, no, we were wrong here, and they will own up, and they will find another solution around, or they will basically withdraw from the project.
Talking about you can choose any technology you want, I can imagine that the staff needs to use your technology afterwards, right? So they have to work with it. Is it
Sure, absolutely. So you have to. I mean, if you do use a new language or a new runtime or something like that, then you have to be able to justify that, and you have to provide the support, and training. It's usually. I mean, the reality is that we try for solutions that are very, very narrow, so that they have impact at a particular point, and the sort of surface area of the technology is very small. So you're talking about, maybe 2 or 3 people that are needed to actually maintain this technology. That could be done externally, or it could be done internally. So if the benefit is high, then and this can be supported by 1 or 2 people, then typically that's not an unreasonable cost, and that has to be costed into the overall cost of doing things.
You probably don't want to outsource it, because then you have the knowledge outsourced. It's probably good to have 1 or 2 internal people.
It's usually a good idea to have somebody. I mean, a combination could be good too, in the sense that you say, okay, we'll have our internal person or 2 people, and we'll also have a relationship with maybe the supplier over a 5-year period or something like that, and say, okay, they will also always help us guarantee that we have these 2 people on site, and you can also provide the tech. And sometimes the technology is really important to get something done, but it may not be. In other words, it may accelerate the time, you reduce the time to delivery significantly so that you can deliver it in 4 months. But it may be that you don't need to depend on that technology. So you could say, look, we can rewrite this over time from, we implement it this way because we wanted to get it done quickly because it was important. And we can now replace that with a more conventional underlying technology over a period of time, but you have the benefit there. So there's I mean, you have to provide the customer with a set of choices. But usually, if the benefit's significant, the fact that the technology is strange is not the issue.
Okay.
I mean, that's the whole point of doing something where the benefit's significant, right? Like if you go to Agile and you get 5 to 10% across your company, who cares, right? I mean, for all this disruption and for all this other stuff, I mean, it doesn't make a significant. Who's going to stand up and say, look, we got this amount of value in 4 months with this one team, right? You have this big systemic change, or we're rewriting this whole thing to get exactly the same thing in a new language or whatever. I mean, why bother? I mean, so I think it's really about having a very focused innovation, and not creating a big dependency on the technology. I mean, when you go from one, pick whatever it is, COBOL to, Java, or Java to JavaScript, or when you make a big change like that, you just spread this risk all over everyone. So I mean, if it's inappropriate, you've sort of made this whole global change, and now everyone's dependent upon this technology. You may think that's good, but in practice, you have a much bigger risk. Versus if you just define, if you can define a small dependency, and then people can rely on that dependency. Often people don't need to actually change all the underlying technology.
Okay. Nevertheless, I want to talk about improving the code base.
Sure.
Although, it's not measurable, but
I mean, there's lots of measurements of doing that. I just think it's a waste of time.
For instance, for me, it's like, okay, if I have certain parts of the application where we have lots of commits to, we see every day.
Sure. Oh yeah. No. If you have pieces of code that are sick, that are not well, which you see by evidence, commits, defect reports, whatever, it's absolutely sure they should definitely be improved.
Even if you cannot really measure it in a
Well, I
sense.
mean, I think
again,
you can measure that. I mean, if you can tie that back to customers or the cost of development or the cost of quality of the customer and so on, I think that's a good thing to do. But it's hard to do in a systematic way. I mean, you should do it to the important people, the things that are important in your system. So you should look at the important modules. But a lot of the time, the biggest thing you should do is delete code. So the most important thing you can do is get rid of code. So, but that typically means some amount of fairly major rethinking or rewriting. It's not just fixing up local code. I mean, when you're in a module that's got, you would like a system when you open up a module to work on it, whatever that module is, a class or a group of functions, or you should see all the bugs that are there. Like they should all show up to you as little bugs or something like that, and you shouldn't just fix yours. Ideally, when you open the module, if there's a bunch of bugs that are obviously right near you, you should fix all the bugs in that module. Or if you can. However, if you're in the code base which doesn't have good test coverage and things like that, there's risk associated with it. The time allowed to fix, you're only allowed time to fix that one bug, then
it's difficult. Yeah.
I think in most cases I've found it's easier just to delete code and rewrite it than it is to actually try and improve it. So I'm not a big fan of incremental refactoring or so on, especially of other people's code.
And
I think of your own code as you're writing it, that refactoring is an important part of the thinking, programming progress. But I'm saying when you approach code that was written a year or two ago, you have a different, and it's not yours. You don't have the same intimacy with the code and moving it around and so on.
So it would be a good choice if I work on a requirement which is based on old code. I might throw it away and rethink the solution to implement it instead of saying, I make it a bit nicer here and there.
Yeah, well, again, it depends. I mean, I think if the problem's small enough, it's easy to rewrite the code. But I'm not sure if the problem's small enough that it's easy to rethink and write the code. I'm not sure I would even bother giving someone that problem.
Yeah, exactly.
Yeah, right. I mean, in the sense, I think that's. I mean, the end in most businesses, there are only you have things that are number 1, number 2, and number 3. You just delete everything that's 3 and below because you're never going to get them done. And you try and get all the 1s done and as many of the 2s as possible. So if you have code that's really difficult and really risky, then clearly improve it. But I would often argue that you will change. I would innovate in how that code was written and architected. I would not spend my time trying to massage the code so it smells better.
No.
But, obviously you have to judge. I mean, this varies from place to place. So.
Yeah, my measurement of judgment is the idea of strategic design. I think Eric Evans, he mentioned it once, that he said, well, some parts of the code are messy, you cannot change that, but the code which is really important to the business, which brings value, that should better be great, and there you need to have a look.
Sure. I mean, I think we're saying the same thing. It's just that, well, one of the first things you can do is delete the domain models, because that's a big waste of time. Most problems with a lot of big code bloat and mess in most OO systems is there is no domain model really. It's just there because the people are programming with objects. So that would be one of the first places when I find you do domain models. Domain models are good for thinking, but they don't belong in code, most OO code. Because they're not objects, they're just data and transformations. So I think a lot of people that use OO models and persistence frameworks, when you want to improve something, delete those. That's a big performance and big code bulk gone.
Just deleting my Hibernate.
Yeah, it's a waste of time. It's a waste of time and space. Big performance, all that stuff. ORM's first thing to be voted off the island.
Mm-hmm.
Right? In the end, it's data, it's records. You want it to be records. There's no behavior. They're not objects. They don't have any behavior.
Mm-hmm. Yes.
So you get all this object inefficiency, serialization, conversion. From that's one place to really make a big difference, right?
Yeah. Just delete the domain model and then have the queries transform the result and display it on the UI.
Why not?
I don't know. I think I heard it 1.5 years ago that you don't need objects. Just have a query, a functional transformation, and display the data, and that's it. For a lot of that would be okay.
Yeah, the reason we're using objects is because of mid-tier servers. It's because the technology we were provided with was Java or C#.
So
because the middle tier server was written in an object, so the technology implementation. So then we converted the solution so we could only work with objects, right? So because programmers, they like objects because they learned all this objects, so they make the objects into, they make the data into objects, and then they make it back out into serialization so they can send it either way. And so it's because people wanted to work only in one technology. I mean, that's what really motivated it. In my opinion, right?
We were talking about tests, that tests are missing. Is it a good idea to add tests to a legacy system, that eventually you have the system completely under test?
It's always a good idea to add tests to any kind of system. The important thing is to add tests with values. So you should add acceptance tests, or you should look at something like model-based testing, where the tests are generated from a model. You should not waste your time writing unit tests and things like that, in my opinion. In my opinion, far too much time goes into unit testing relative to writing acceptance tests. Clearly, if you can do both, that's great. But in the end, acceptance tests tend to test more things from end to end, and so they're, in my opinion, a higher value. And that's what the customer pays for, and they will keep you honest.
I think there is a big debate that unit tests are waste.
I don't think it's a debate. I think it's a known fact. I just think the Agilista don't want to admit it.
I can imagine if your unit test might work, but the collaboration of all objects, that doesn't work then, and then your unit tests are wasteless.
But again, I think the problem is that there's lots of great. I mean, when S-unit and J-unit were written, they weren't for testing setters and getters, right? And we believe those work already. That's why we have programming. So I think if you sort of test something that's with an interesting set of interactions with a unit test, now we're really. So a set of tests that tests a class, for example. That test to test a fair number of interactions and so on. So that might easily be something written in with JUnit or whatever, or XUnit, and that makes perfect sense.
But you said model-based testing. For me, I thought always model-based testing is rather an academic approach. How does it work?
Well, that's like most people who reject academic approaches prematurely, right? You have to watch and see what's happened. I think if you see right now in the functional programming area, everyone uses some version of QuickCheck. QuickCheck, essentially, you write a model for your code and then it generates random tests, and it'll generate millions of tests where you could write a few hundred. So it is the best practice in testing today.
Okay.
So, but unfortunately, it's been applied mostly in the functional world, but there are versions of QuickCheck now for almost every. And parameterized testing has been known as being very effective. The nice thing about QuickCheck is that random tests you get a lot of false positives, And the nice thing about quick check is it reduces, there's a reduction step that reduces the false positives. So it actually filters down. So, it basically gives you the coverage and the benefits of randomized testing, but you don't have to look at a million random results. It actually filters the failures to find the ones that are important. So,
Okay, wow, that sounds interesting.
No.
Yeah.
I mean, if people aren't using things like quick check, they should be, because it's so much better than.
Okay.
And it's just de facto in all functional programming languages now. But there's quick check for JavaScript, there's quick check for Ruby, there's quick check for Java now. More and more people using it.
Okay, cool. Who's developing quick check?
Well, quick check was developed by John Hughes, very well known in the functional programming world. And he did it first of all for Haskell, and then he did a commercial product for Erlang. And it's been applied now to stateful systems, test level DB for Google, React, some very complicated stateful systems. So it's a really very exciting breakthrough. I mean, it's been around for a while, but now it's in the mainstream. So.
Damn, I'm not in the mainstream.
Well, yeah. We all the world turns, and
Yeah, exactly. But still, if I want to introduce tests, I probably have to change code, right? That's a risk we have to take. I cannot test without changing code to make my code base testable.
Well, it depends. I mean, you can drive a lot of acceptance tests from the edges. It's certainly harder because you can't insert the code into a specific point, but you can certainly cause more paths to be executed by understanding the path you wish to test. So
exactly.
So I think if you understand the parts of the code you wish to exercise, because for instance, you have code coverage tools, or you should have, right? Then you can say, oh, look, these cases are never really covered, so I should put some tests in here, which will cause these paths to the code to be executed. Sometimes it can be quite complicated to set up the test, to get the system in a configuration and so on. But if it's hard to do that from the outside, it's probably
Very
also hard to do it from the inside.
Exactly.
So I think good testers are actually pretty good at figuring out. If you look at code paths and if you look at the places, again, if you do it from a sort of value point of view, you look at the points where you look at the modules where you have a lot of failures reported, where people keep committing fixes, but
introducing new issues.
New issues. Then you can say, well, this is an area where clearly if we had better test coverage, then maybe those people could be more successful to make the changes, because maybe they just aren't aware of the interference between what they're doing and what other things are. So it'll often end up that you find out some piece that just needs to be, at least split up into smaller pieces so you can kind of get them under control. Right?
Yeah, but again, you need some numbers to verify that introducing the test is really valuable. Like you said, when I fix bugs and introduce new ones, and the code base doesn't have tests, probably better to introduce them. If I fix bugs on an untested code base, but in general we don't see new bugs popping up, then it's probably not necessary to introduce them.
Yeah, I mean, you have to kind of look at the value and the risk. I mean, it may be, for instance, that you have a system which hasn't, it has some cases which are never executed because maybe the company didn't turn that part of the system on, right? There's something for handling, the credit card part is turned on and it's working heavily, but the debit card part isn't used because no one's decided to sell debit cards, or they're not popular in a given country or something like that. It could be that you really have a big risk sitting there because that code's just not executed by current transactions, but in fact is full of bugs. So, that's a case where just because, you don't have many bugs, you don't have many bugs because the code isn't being used, right? So you have to kind of look at, okay, why is this code, quote, good? Right? It's good because it doesn't get executed, right? Well, that's not necessarily true. So,
Okay. Which tools do you prefer for acceptance testing?
Well, I think it's not a tool problem to me. It's I mentioned QuickCheck as a very important tool to generate tests, but I think to me it's really not a tool problem. In the end, it's you need to be able to express the test and run it frequently. That makes it difficult. If you have to run them through the UI, then that makes it difficult. So you like to be able to test against an API of some sort, but I'm no real. Maybe I'm ignorant of some great tools that work, but I don't find anything. But in general, I prefer not to use any kind of testing tool. I really even QuickCheck, you can't really use it without writing a model. So it's actually a programming activity. It's not. So I think the notion of a tester not being able to develop will be historically the notion of having testers who aren't sort of intimate with the domain or aren't intimate with the code. And possibly both will just go away. So the idea of a cheap tester using QTP or even I forget the name of the popular open source ones.
Selenium?
Selenium.
Yeah.
Yeah, I don't see that as a long term. And clearly, there's a real need for a breakthrough in GUI development and testing. And I don't see any. I mean, the best practice I know is you basically every few weeks to most 2 or 3 months, what you do is you have a code freeze, and everyone pounds on the code, and usually that finds tons of obvious bugs in the UI, and so you have a huge bug. You basically in a week you find hundreds of bugs, and then you go and fix them. And usually once they're fixed because they're stupid UI cases, and writing all the tests for those, from my point of view, would be a big waste of time because they're never going to appear again. So that, from my point of view, tends to produce better quality UIs tests than others.
Yeah. Okay. It's 2015. We need to talk about microservices. I heard it quite often that improving legacy systems by extracting services is a good idea.
That's what SOA said, right?
But microservices are SOA done right. Is that true?
I guess so. I don't know. I'm certainly not a microservices expert, so. I think microservices is a. I mean, anything that lets you reduce coupling will improve. Gives you flexibility with regard to your software. I mean, the big problem we've had is because we've had to have things in the same memory space, and we've had to link them all together, and we have all this inheritance and sharing, is we have much more coupling in object-oriented systems than one would like. And that's why, I would rather work on a COBOL legacy than a Java legacy, because the COBOL legacy is much less coupling in terms of improving, refactoring, much safer place than working in an object legacy, because the complexities of the couplings is much higher. So I think it's natural that if you can have things that are more isolated, then that gives you much more flexibility in that regard. However, we've seen lots of things implemented with microservices that because the signatures and versions and so on are of the different services are there, they're still tightly coupled even though they're microservices. So it really has to do with being able to design this. It really comes down to designing the services or the service architecture such that you have these things with a single responsibility principle and so on. In which case I think it has lots of promise. I think the challenge is you want to have an application architecture that leverages a service architecture. And I think right now most service architectures are really kind of system architectures. They're the core system, maybe core application. But I think you want to have the variability introduced in different ways above that. I don't think that's something that's really been. I suspect that good service-oriented architectures, good microservice architectures do that. But a lot of the rhetoric is that everything can be small and easily changed and so on. And maybe that's true. But again, a lot of it is also, well, we do this on new systems, we don't do it on old systems, right? So, if you hear Fred and other people, they say, well, this is for, the new companies, right, doing the important fast things and so on. It's not for people doing a payroll system. And so I don't think that's true, but I think you'll have to have a different model for doing that, where you'll have a core, which is microservice based, and then you'll have some way of dealing with the variability of the business rules and so on, and there, which could also be services right now. But I think there'll be more service engines as opposed to service applications. But no, it's certainly quite promising. But once you get lots of services and lots of programmers, you have the many of the same potential pitfalls, right? But isolation and so on is really exciting. I mean, to be able to do that, right, and use machines. But I mean, connecting everything through correlation IDs, debugging all these things, these are challenging things to do for 200, 300, 500,000 services, right?
Infrastructure, deployment, it's tricky. Yeah. One thing we didn't talk about yet, although I think it's one of the most interesting things about legacy systems, the data. So
absolutely, the most important thing.
Yeah, so that is the thing which is really the value of a company. It's the goal.
That's usually the place where we go to innovate, actually. But
yeah, okay.
Because most people don't. They worry about the code.
Yeah, what I see quite often is we write really weird code around broken data. So inconsistent data or wrong data introduced by previous bugs. So cleaning up data is a good choice.
Yeah, it is. I mean, data science is much worse than that. So big data is far worse than most legacy systems, right? Because most data, logs, and so on are actually terrible. So most corporate data is actually much cleaner than click streams and so on. So I think it's more of a challenge. Cleaning up data is more of a challenge for data scientists. But I mean, the good news is most data is in databases. So that actually makes it pretty easy. Now, people do some funky things in databases, and you do get lots of CSV files and other things around. But cleaning it up is very important. I think the real challenge is actually getting reasonable descriptions of the data and understanding how to fuse it properly, so that, and some of the data will have problems, but I don't think cleaning up data is the highest order thing.
What's the highest order
highest
thing?
order thing is being able to get to the data quickly and being able to fuse data from different sources in the organization. The biggest problem a lot of companies have is they have the data in 3 or 4 or 10 different systems and they can't get at it in reasonable time.
Okay. So it's not the problem that we have the data which are a bit messy in one database. It's the data are distributed in very different formats.
Right, and even
hard to aggregate.
Yeah, that's right. And once you can actually look at the data from 5 databases, you can actually start looking. You can then be aware of the inconsistencies. But if you can't actually fuse the data, you can't even know that you have 4 versions of the customer. Right?
Okay.
Yeah. So I think the biggest problem is people can't get at their data fast enough, and they use a lot of bad techniques, like trying to put APIs into all these integration services and things like that, SOA, and have SAP APIs and Oracle Financial APIs and all that, and then they build stuff on top of that. And those APIs are almost always bad wrong term. They're limited because typically the APIs are added by the vendor later, given the demand by customers to have APIs. So they don't actually provide you a consistent view of the data. So if you actually, if you have data in a legacy system and you say, okay, you can get the data through these APIs or services, if you want to give a nice name to the API, right? Then the problem is those services very seldom will actually give you. It's usually given a vendor's APIs. It's not possible to actually see the data, all the data that's in the system. So the APIs are sort of implemented on a need basis. Oh, we need the customer name and account. Then later there's some other piece that you need, so there's another API. So the APIs have sort of been added by need, as opposed to being systematically defined. So there is no API, for instance, that would allow you to take all the data in the database and take it out or put it in. To do that, you'd have to use the screens of the enterprise application or whatever it is. So I think the big problem is you can only get a partial view of your organization by using the APIs. And many people rely very much on doing data integration via these APIs, and that's cumbersome and they're not queryable. So in general, I think, and that's where people spend a lot of time. Unfortunately, there are other ways to get around that, but most people don't use those, so that's good.
Good. We're almost done. Is there anything important I forgot to ask?
I don't think so. I'm sure there is, but
on my list is actually many other things, but we probably need to make more shows.
Thank you very much for the time.
Thank you. It was good to have you.
Always good to be with Software Radio.
Yeah, it's already your second time, right?
Yes.
Okay, I want to mention that the feedback of the listeners is very important to us, so please help us improving our show and leave your opinion on Twitter, G+, or LinkedIn. This is Sven Johan for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.